Hi, I wanted to do a video on how computers work. Let's see, mainly for my parents, but of course whoever wants to watch it can. Yeah, I tried to search on the internet for different YouTube videos and didn't really find anything that was that great on just an overview. So I put together this and let's see how this goes. Okay, so here we have different computers. Um, I'm counting everything as a computer: laptop, cell phones, smartphones. Old dumb phones possibly don't count. Uh, but yeah, so laptops, and then of course your desktop here, um, and another laptop. That's an Apple. You get the idea. But yeah, so basically a computer is what you've got: some sort of output device, monitors, printer, and then you've got some input device, which is your keyboard, your mouse, and then even CD drives. Old CD drives can count as input device. It's also storage, depending, I suppose, on how you think of it. But yeah, it could be to store data. But then also, if you get a DVD from a store with a movie, of course, that's sort of like inputting to the computer. So a lot of times there's back and forth. Um, and this is, a system here they're showing, but laptop has that all built in. And there's some sort of storage device. Often, of course, this has a hard drive as well, which would be one storage device. But you could have external storage device as your DVD drive, for instance, or your external hard drive, a USB stick. Okay, let's see. So basically, there's, let's say, hardware and software side. So first, we'll start with the hardware side. You have some input-output devices, keyboard, mouse, as I mentioned, output devices, monitors, printers, and that goes to your computer, which basically your motherboard, which has in it a central processing unit. Um, and I'll go into a little more detail on this, but yeah, central processing unit, and then that central processing unit processes the data like key clicks and stuff, and then sends that to RAM, uh, short-term memory, hard drive. RAM is a short-term memory, and then it also goes back and forth with the hard drive, uh, reading and sending data to it. I guess I should have put more arrows going up, honestly, but this is okay. But yeah, so also that would go to your probably like something like back through your CPU. So these should probably be two-way arrows. Um, and yeah, actually, there definitely should be two-way arrows. But now it would go to your output device. So your input comes in, and then it sends it from there back through to your output, like your computer screen. Um, and then, yeah, so let's see. So here, let's take a look at our motherboard. So this is, say you have a desktop, old school desktop. Um, you have some sort of power supply to power everything. Whoops. To power everything. And then yeah, this is a case, so there's of course hardware. But okay, so they have your motherboard, and your motherboard has CPU, different ports for input and output, like your monitor, video monitor, USB for USB thumb drives with extra storage space, different connectors for your extra monitors, maybe connected to a TV, connected to an external CD drive. Often there's USB these days. But okay, that, and then you have some RAM. This is some memory, random access memory slots. That's like short-term memory. And then somewhere on here, you would also have a hard drive connected. Now it's usually SATA. Um, but yeah, so that's basically how that works, and we could go through this a little bit more in detail. Okay, so the brain of the computer is, well, I'd say brain, but that's hard. It depends on how you think about it, but it's at least doing the calculations, right? Their central processing unit is your CPU. So this one they talk about approximately like 2 to 4 gigahertz. Like how many cycles per second is a hertz? How many gigahertz is your CPU? And there's approximately 1 billion transistors on a chip. So this tiny thing has 1 billion transistors. A transistor is like a little on-off switch, like a light switch, say, that controls current flow, electricity flow. But instead of your finger doing the on-off flicking, it's a voltage. So one transistor can control another transistor. But yeah, so here's some transistors drawn. So this is an NMOS transistor. It's basically silicon. You don't have to worry about the details, but basically you have your source and your drain, and then your gate, and a voltage there, and then a voltage controlling. It's like a valve. It'll control the flow of current from in into output. And yeah, here we go. It's like in the off state, and in the on state you have voltage there, and then it makes a channel for electrons to flow. Now you can do fancy things with these. So here's just what we call an, let's see, 0 zeros. Oh boy. Okay, this is I think a NAND gate. 1 0 here 1 1 is 1 0 1 0 is 1, or maybe it's a NOR gate actually. Okay, so either way, what it is that you have different voltage. You could put a voltage here, or a voltage there, or no voltage there, no voltage there, or voltage on both of them, and then you're going to get some output. You know, and is it going to be a 1 or a 0? So now we talk in binary. Voltage or no voltage is like a 1 or a 0. And when we talk binary is computer language, right? And yeah, so here you get this table. Sorry, a table there, and it's 0 0. In this case, output's a 1, and then 0 1, output's a 0. So with this, this is one configuration, and basically from this you could make all kinds of logic. So it's called a logic gate. From this you can make a small. With many of these, you can make an adder to add numbers, and then you can make a let's say memory storage, and then eventually you could do very complex tasks like playing a game, for instance. But yeah, so this is basically billions of these sort of circuits, or billions of these transistors, so many hundreds of millions of these kind of circuits in this tiny thing, and you could sort of do calculations. Okay, so we have that. So from that, like our brains, you know, we have short-term memory as well. So you do the calculation and then you send it to short-term memory. Random access memory is called. And this is when we talk about, oh, you have 1 to 16 gigabytes. So if I say I have 4 gigabytes of RAM, that means short-term memory. So your computer needs to do the calculation, send it to short-term memory, so it could work with it. It's like sometimes heard it called working memory. And then it goes back and forth sort of to the CPU. And then sometimes you also want long-term memory storage, like if you have a large game. So say you're playing a game, the game maybe you downloaded it from the internet or somewhere, stored it on your hard drive, and then that, as you're playing it, some of that goes into your short-term memory, your RAM, and then it goes into your CPU to process, and then it sends it back to RAM, and maybe it saves some data to the hard drive if it's going to use some settings or whatever, and then at the same time, of course, sending output to the screen and sending output to if you want to print something, I don't know, or if you're, and at the same, of course, you're using a joystick or keyboard, and it's, so the CPU is kind of handling all this, using the short-term memory, and of course your storage, your long-term storage. And this is when we talk about approximately 256 to 1,000 gigabytes. So often we'll say like we have a 500 gigabyte hard drive. That's your long-term storage. Or 1 terabyte is 1,000 gigabytes. So here's different forms of long-term storage. In the past, there were floppy disks. Then it went like USB thumb drives. Here's your hard drive. Now we actually have SSDs, solid-state drives, which has become common. But now they're still kind of they're much smaller and much faster. There's no moving parts. So with the hard drive, this spins, which is kind of, it could fail. But you could have solid-state drive. It doesn't have a moving part. It's better, but you don't get as much storage, but it's getting better in time. So, and this would be an external hard drive here, CD drives. So all long-term storage, like large memory or large storage. You still need RAM for your short-term memory to work with the CPU, and then talking to your hard drive. Okay. So now in the second part of computer, you have your hardware. Okay, hard physical items, and then you have some software. And that's actually things that are programmed, like these need to be changed. How can you write a game, and you have to be able to change states of things? Okay, so you have the software. First, there's different tiers. Let's see, you can think about it. You have a BIOS, which is part of your motherboard, like that physical hard drive. It's usually a chip. I'll show it on the next slide. Your BIOS is your basic input-output system. That's what does the real um, uh, it makes everything talk to the hardware. And then you have your OS, your operating system, which is, say, your Windows, your Mac, okay? And then you have your application and programs like Firefox, Chrome. That's like the higher level. Okay, so here we go. Here's the BIOS. Usually when you first turn on a computer, you see something like this. It's basically the BIOS talking, and it's a chip on your motherboard. This is on your motherboard. There is a battery usually that BIOS needs to save the data. Okay, and or actually, I guess it's usually to save the clock information, the time. BIOS should be kind of stored read-only memory, so it can't change. ROM. Yeah, I'm probably not perfectly right on all these things, but you know, getting just the gist of things. Okay, but that's your BIOS chip. Okay, that shows and makes sure all the hardware is connected properly, and it allows the computer then to talk to the operating system. And your operating system is like your Linux, Mac, PC, or Windows here, right? And your operating system will use that to talk to your keyboard, mouse, hard drive, applications, you know, like Firefox, Chrome, and Microsoft Word, perhaps. And let's see, and then we have also, of course, your monitor and your printer. So your operating system is like the software in charge of everything, right? You can think of it like that. The BIOS makes the hardware run and allows the operating system to work, but like the but the the BIOS allows everything to work, but the operating system is really what's in charge of things. So okay, here we can look at another diagram. So you have your applications that talk to your operating system, and that talks to your hardware. And I would argue through your BIOS. So different applications and programs. So here we could look. I just wanted to put some examples up here. Internet Explorer, Chrome, Adobe. This is like PDF files, mail, all these things will talk to your operating system through your operating system, but these are the standalone programs written in some language. Sometimes they'll say written in C++, you might hear, written in Python. I mean, you could write some programs in Python, but like these are written by programmers, as is your operating system also, but these are applications or programs, and then they talk through Windows, and this is Windows here, Windows 8 or Windows 10 it looks like, and you could see all the different applications, and these are all, again, more applications. Okay, so I wanted to talk a little bit about the internet and how that maybe works. So okay, the internet is like a way that we could communicate from one computer to another, and storing data and sharing data. So you have clients, that's like our home PCs, our home personal computers, our laptops, and then they talk through a router or modem. This is like you have a cable modem, or you have a Wi-Fi router, which also usually is attached to a cable modem or a DSL modem. And then this talks to your ISP, your internet service provider, which will be like Comcast or Cox or so things like that. And then that talks back and forth with, say, DNS servers. DNS servers, this is like directs where to go with different addresses, if I remember correctly. And then that eventually goes to servers somewhere, say like Google. Google has massive servers somewhere. These are just servers, just a very large computer, you could think about it, with a lot of storage, a lot of data stored on it. So they have servers with say your mail, your Gmail, and with many web pages sort of built into it, or search results. A lot of information. Facebook has servers, so basically this, and then this goes back to your router, and then it shows on your screen. So basically you would type in www.google.com, it goes through your router, and it's the first router, to the server. Okay, it pulls what it needs, and then it sends it back. Okay, so that's a good overview of that.